Now, another way we can look at this is say it's really about the effort to add new features. If you've got a clean design, it's a lot less money to add a feature. There's a cost for that poor design, which is incurred every time we add some new feature. And this leads us to another very powerful metaphor for thinking about the consequences of taking that no design curve. And this idea comes from another very influential person in the software development world. How many people recognize this guy? Hopefully many of you ought to. This is Ward Cunningham, one of the biggest and most influential thinkers in the Agile world, and most famous in the more general population because he invented the wiki. The original source of things like Wikipedia. This all depends on this guy. Who wrote the first wiki in 200 lines of Perl back in the mid-90s. Now he said, well, we can look at this notion, but what happens is this unnecessary complexity in a code base causes and is tied to this increasing cost for new features. So he came up with this metaphor of technical debt to deal with this. He said, when you've got this case, you've got a choice, which is very much like a financial debt. You've either paid down the debt by paying off the principal, or you accept the debt and you keep on paying interest payments, which is the extra cost for new features. What you've done when you've had a less than perfect design is you've taken on some debt, and then you have to decide what you're going to do with it. Do I pay down the principal, or do I keep paying interest? And the nice thing about this metaphor is I've found it does speak well to people who aren't software developers. They can get a sense of what it means and what the trade-off is. Because you have got this stuff in the software that's not good, you've then got to decide what you're going to do about it. And either decision could make sense. Sometimes it makes sense to pay off the principal, sometimes it makes sense not to. It all depends on the amounts, right? If you've got some really crappy code, but it's in a module that you never have to touch, you never have to change, your interest payments are really small, it doesn't matter, you don't have to pay it off. But on the other hand, if you've got messy code in an area of your code base that you're constantly working on, then it's much more difficult, right? Then you've got to say to yourself, well, maybe it is worth paying down the principal and putting some serious refactoring effort in here because I can reduce my interest payments and end up going faster. So that trade-off, using this metaphor, can be a good way to think about it. And I use this metaphor primarily as a way to say, when we've got problems in our code base, where do we go from here? How do we make the decision of which way to go? Now that's, I think, a very powerful metaphor, but it's also worth reflecting on how does technical debt accumulate in the first place? What is the mechanisms by which it appears? Because that's another way of thinking about how to keep it down. And this struck me very much in hearing a contrast between the two. So, one situation that builds up technical debt is when people say, we have an important shipping date coming across. We've got to get this software out in order to meet this particular tax year. We have to accelerate to hit this short-term date. We know that we're going to build up some technical debt as a result of that, and we will deal with it after the date. That's a kind of fairly thoughtful way of dealing with it. That's some situations where technical debt appears. Another situation where you see technical debt, a more common one where you see a lot of technical debt, is when people don't really even know what they're doing in the first place. Right? And then you build up a really crummy code base, and you say, how the hell did this get this way? Well, because they didn't really know how to do good design. And people have argued that this latter case isn't really technical debt at all. I got into an argument with Uncle Bob about this. He said, well, this case, that's not technical debt, because it wasn't done that way. But I find it's still a good metaphor, right? Because you've still built up a huge amount of debt. You've still got to decide, do I pay down the principal or do I keep paying interest payments? But what's happened is that the debt has arrived in a different way. One of the big differences here is the case where people are making a deliberate decision to take on debt in order to hit an immediate deadline. They were thoughtful about it. It's a difference between a prudent and a reckless debt. You get this in financial terms as well. Right? The first people, they were looking at the figures, making a decision. You know, you can't quantify it as precisely as a monetary debt. You can get a feel for it. While the other people, they were racking up the credit cards, maxing them all out, and then going down to Guido down the road and asking for payday loans, and just getting themselves totally in hot. And we know people do this anyway. Countries do this. Right? I mean, reckless debt is not uncommon in the world, as we've noticed. There's another difference as well. The first guys were actually thinking about it. But the second lot, they weren't even aware that they were racking up the debt. It was just kind of invisible to them. So you notice what I've done is drawn a pair of distinctions between these two styles of debt. Prudent and reckless, deliberate and inadvertent. But what I've really done, of course, now, is I've reached this moment of consulting nirvana. I have created a quadrant! Yay! If I work for Gartner, I'll get a bonus. The interesting thing about a quadrant, though, is that it forces you to ask the question, well, what's in those other two spaces? What do those look like? Now, that top left one is quite interesting, because it's actually very similar to the top right one. It's when somebody says, we don't have time to do good design. We've just got to go fast. Right? And this is, it's deliberate, but it's much more reckless. And what often happens here is that people aren't really fully understanding the consequences of my little pseudograph from earlier on. Now, when we look at this pseudograph, what we say is, yeah, there is a point at which you can make some short-term sacrifice in order to gain speed. But you've got to know you've got to pay it off, and it may well be reckless doing that. But there's also this very important little point here that says that if you try to trade off attention to design in order to go faster, and you're above the design payoff line, you're actually going to have crappy code and go slower at the same time. It's completely a waste of time. Now, the awkward thing is, of course, we have no way of measuring where that design payoff line lies. But my qualitative sense, based on my experience and the people I talk to, is it's in weeks, not months. It's much, much shorter than most people realise. And the sad thing is that most people who are doing this, we don't have time for design, they're actually shooting themselves in the foot. Because they're actually slowing themselves down by not paying that attention. And that's one of the things that we as software developers have to be better at explaining and making this argument from an economic point of view. We're not paying attention to design because we want a beautifully well-crafted code base that's wonderfully clean and easy to work with. We're doing this because we need to go faster and we need to maintain that speed, even though it's now a 9-month project. We're still going to end up going faster if we produce good quality code. And that, I think, is the crucial argument to make. The economic argument in favour of good design. If you turn it into a moral or professional argument, you will lose, I think, pretty much every time. I mean, yeah, you'll get sops when the managers say, well, yeah, okay, we can spend a bit of time on design now, or something. But you'll only get those sops at quiet moments, and they'll only be occasional. There's no real commitment to that. So then that leaves us with our final quadrant. Prudent, inadvertent debt. Now that completely breaks the financial analogy. I can't think of what a financial case. Some people sometimes come up with them, but they never really work for me. What am I talking about here? Well, I think it's nicely summarised by a conversation I had with one of my colleagues a couple of years ago. What I do a lot, because I don't do any real work anymore, I spend time talking to my colleagues who do, and so I can steal ideas from them and present them at conferences like this as if they're my own, so you think I'm clever. And I was chatting like this with one of my colleagues in London, and he'd just finished with a project. It was about a year long. The project had gone very well. The client was really happy, we got really good software, the team had done a good job, but I could tell that he wasn't so happy. I kind of probed a bit about this. And he said, well, our design was really pretty crummy as it ended up. I said, well, but Ben, you're one of our best tech leads. I can't see you making a crummy design. And he said, well, I didn't do it deliberately. It's just that now I realise what the design should have been. And it wasn't the design we originally did. How many people have had that experience? Yeah, pretty much everyone, right? I mean, the thing about software is you don't really know how to design a new piece of software until you've at least made one shot at it. This is why Fred Brooks made this comment, plan one to throw away, you will anyway. Because of the fact that he knew it's by actually building the software that you figure out what the good design is. And this is where a lot of the design up front stuff ended up breaking down. A design that looks really good in bubbles and arrows on a diagram, when you actually have to build the damn thing, you begin to realise, oh, it doesn't look so good now after all. Unless you're a really, really talented designer. And even I would get it wrong all the time. I was supposed to be a kindly joke kind of thing. If you don't laugh, it makes me sound even more arrogant than I am. So, this is a regular thing. But again, it's another source. What do you end up building? You end up building technical debt. You do really good work and you realise, oh, that's not as good as it could be. Well, as soon as you realise that's not as it could be, that is an amount of debt. In fact, this is the technical debt Ward Cunningham was talking about. Now, even Ward creates technical debt. So the rest of us definitely do. And then you've got to decide, again, it's the same payment issue. Do I pay down the principal? Do I keep paying the interest? And that's why, of course, refactoring, even the best teams will always be refactoring, because they're always figuring out, oh, this is what it should look like, and then they're using refactoring in order to get closer to that point. Now, this is another thing to have to explain, of course, to people, is that this kind of debt, even the very best teams will create technical debt of this type, even if they're operating on all the way in good quality in other sense. And of course that lowers the headroom for taking on other kinds of debt, because there's always a certain amount that you're creating anyway. So I find this a good way of thinking about why design is worth it. It's an economic argument. It says good design is what we need to do for any project that lasts more than a few weeks. And we do it because we want to provide the best return on the investment people are putting in to the software. And if you want more on that, I've got a bunch of things on the Blinky. At some point I want to have a really coherent written thing on it on my website, but I haven't got there yet. And that, I'm pretty much out of time. So I usually want to do some questions or something like that. Okay?